Hello everyone, welcome to this video. In this video, we'll be discussing about Azure AI Search. Azure AI Search, it's a search engine. We all know what does the search engine do. So you will have enterprise data, you pass the data to the search engine. Search engine will create an index, and like using the search method, you can retrieve the data and use it in your application. Azure AI Search provides the traditional search experience where like you can do a filter, scoring, synonyms or whatever is that. And on top of that, it also provides AI-based retrieval. Say like you have a embedding using the hybrid, you can use the keyword-based search as well as the embedding search, combine it together. And then you can send the top results to the LLM and generate the final result instead of just having the chunks. So before we move forward, we will try to understand the difference between the traditional keyword based search and the advanced embedding based search. So let me navigate to this particular portal. Let me search for the keyword Zapier. So basically like I'm looking for a eye drop. However, like if you see here, this particular e-commerce portal does not have this particular product. As it uses the keyword based search, it is not returning any values because like there is nothing they have it with the given name. But if you see that if they don't have this particular product, they should identify that this is the eye drop, and then like they should display all the relevant eye drops. So now let me navigate to the another portal here. If you see this particular portal, I just say like the same keyword. However, like even this e-commerce portal, they do not have the products. However, like they recognize that this is the eye drop, and like they showcase all the alternative. So if you see here, this e-commerce portal uses the advanced search, wherein this particular portal uses the keyword search. So the main difference is that keyword search will look for the given keyword, wherein like the embedding or the RAG based search will not only look for the keyword, but then like it will also look for the synonyms. Now with that understanding, let's go to this documentation and try to understand. Now we will try to understand the pipeline here. If you see here, first we will have a data source. Sometimes it may be a storage account, sometimes it may be a SQL server, Cosmos DB, or anything for that matter, right? And then like we will have an indexer. It's think of this way, it's a scheduled automation, so that will go to the data source and read all the latest and greatest information, and it will create an index. So indexer will be using skill set. For instance, like let's say like you have a video file or an audio file or a PDF file or a Word document. So the indexer should be able to extract the data out of all of these. So for each of these content, you will be using a specific skill set. Say like there will be a one skill set that will let you read the image. There will be another skill set that will convert the data into the embedding data, right? So the indexer will be using n number of skill set to create the index, and like finally it will commit that data into the index table. Now let's also talk about the types of search. I already mentioned that there is a keyword search or a simple search, and like we also have a vector search. I showed you like what is the difference between all of these, and like there is also a third category called a hybrid search. So hybrid search basically it does both the keyword search, the embedding search, and like it combines the result to produce the final result. And then like we also have a hybrid plus semantic ranker. So if you think of this way, like it's kind of Lego pieces, so you can stack them on top of each other. So first we will have a keyword search and vector search. Both are sits at the same level, and the like hybrid search, if you think of this way, like there is going to be a Lego that connects both the keyword search and the vector search, and the like on top of that hybrid search we have this semantic ranker. So the semantic ranker will take the result from the hybrid search, and like it will apply its own formula to optimize the search result. The order of the search results will be optimized using the semantic ranker. Then finally, all of these are uses the algorithms, a simple search, vector, hybrid, and the like semantic ranker. All of these uses algorithms. And the fifth one that we are going to talk about, it's the knowledge base. This is not necessarily the algorithm, but rather like this is a pattern. So until this point in time, like what we will be sending back to the caller, it's kind of a chunk, right? So in this case, like in the knowledge base, what it will do is that it will take the chunk out of this semantic search, and like it will use the LLM to convert that chunk into the final result, so that the end application will not be receiving the chunk, rather like it will be receiving the processed final result. So if at all you wanted to showcase top 3-5 results, then you will be using these any of these search type, keyword, vector, hybrid, semantic, any of these. Whenever you wanted to showcase, hey, like you were searching for this particular item. So in this case, I say like we are looking for this Zaditor product, and like there is no final result here, rather like we wanted to showcase the relevant product, right? So in this case, like it makes sense to use any of these types. Most likely it will be the hybrid plus semantic search. But then like in case of a chat application, you don't want to have n number of result, or rather like you wanted to have the final result. So at that point in time, you wanted to use the knowledge base. So again, the knowledge base, it's not necessarily the algorithm, rather like it is all built on top of the semantic ranker that uses the LLM to process the received number of result to produce the final outcome. Now let's assume that we have the movie database and see like how does the search types will produce the search results. So let's say like you're looking for a keyword called cyborg, which technically means that you're looking for a robot kind of a thing. But then like with the keyword search, it will exactly look for the exact keyword. Cyborg, it will look for the exact keyword, and wherever it matches, it just returns those film name. But with vector search, it will not only look for the keyword, but rather like it will look for the semantic match. In this case, it will match the robot, machine and all those things, and it will produce the result. And hybrid search, it will take both the keyword search and the vector search, and it will combine that to produce the final outcome. And then like finally we have this semantic ranker. What it will do is that it will take the hybrid output and like apply the semantic on top of the hybrid result. So basically like it will think that, hey, like user is looking for this keyword, what exactly will satisfy the user, right? So from the user context, it will reorder the result. Now, as you realize that the search results are getting better and better, from keyword to vector to hybrid to semantic, the cost and time both will increase. So now let's do the comparison here. So if you see here the cost pyramid, the simplest one or the cheapest one is the keyword search, and then like when you go up to the leader, the cost will keep on increasing because you will be doing multiple process. Same thing for the time pyramid also. If you see here the simple one, it's at the bottom, and like when you go level above, the time will get increased too. So you have to consider both and the cost and time when you think about the search type that you wanted to use. It would be a strategy to select the search model here. So this is the assumption that we are using for this calculation. So if you see here, like we are talking about 100 GB of data in index size, and the like data refresh, it's like 10% of that, which is like 10 GB. And we will be using the standard tier. Capacity, we will cover like what is capacity, and the monthly traffic, like we are looking at 1 million queries every month, and we will be using the small vector based dimension here. And we are talking about the regular documents without any images, without a lot of OCR needed. And this pricing, it's as per May 2026. Now with that assumption, let's compare all four search model here. First we will start with the keyword search. Cost efficiency, it's excellent. So again, like you need to understand that these search model, it's kind of a Lego pieces stacked on top of each other, which means that there is no one set pricing. There will be a foundational pricing, but then like as you add the features, each feature will add you the cost. So the keyword search will cost you about 600 to 750, and then like a use case. So let's assume that you are a specialty store, say like you sell flour or you sell auto part. In that sense, all you need is the deterministic filters. Say somebody will come and look for the sunflower or jasmine or whatever is that, right? So these standard keywords, you can very well use it in your use case. Then you can use the keyword based search. And when you're comparing the hybrid one, it's like a combination of a keyword plus a vector, and the a cost will be about 700 to 950, and the use case will be e-commerce. I already showed you what is the difference between the keyword and hybrid search. Now let's also talk about hybrid with semantic ranker. The cost will be about 1700 to 2000. This will be at the enterprise level. It will not be available for the public usage because the cost, it's a little bit high, right? So say your employee wanted to look for a legal complaints details or a policy details, then you can very well use the semantic ranker. And the final one, it's the knowledge base. So basically it's a rack based system. So the cost will be $3,600 to $13,000. This is mostly used for a chatbot kind of application, right? So now let's move forward. Now let's try to understand the pricing tiers here. So before we talk about that, we need to understand the search unit. So basically let's say you are creating an index. So the index will be your replica. So in order to do a high availability, you will be having a number of replicas. Within that replica, you will be having a number of partition. So say your index size, it's 100 MB, 100 GB. Then you don't want to keep it in a single partition, rather you wanted to have a multiple partition. Why we want to do that? If you just come over here, based on the SKU that you select, the storage size differs, so you cannot exit. Say I wanted to, I'm using S1 standard tier, and the storage that max I can go, it's 25 GB. So say you have a 40 GB, then you cannot have it in a single partition, so you have to create multiple partition. So if you see here, replica, it's your full index, and within that full index you will have a number of partition based on the SKU that you are using. Not only that, there is other reasons too. So if you see here, this search unit, it's the combination of replica and the partition. Say here I have 3 replicas, 2 partition, the search units will be 6. And when to use this scaling, we can very well increase the replica as well as the partition. If you just come over here, we can very well increase the replicas as well as the partition. But when do we do that? So say you have multiple users, concurrent number of concurrent users are keep on increasing, then you wanted to have a multiple replicas so that not everyone will be hitting the same index, but then there will be a number of copies, so they can go into multiple nodes to get the result. And the storage, it's hitting your limit, and then you have to do a partition. And this is where this SKU comes into picture. So if you just come over here, if you already see here, so there are multiple offerings. There is a free offering. So if you're an individual and you want to understand the search capability, then you can use the free tier. But the basic tier, it's for dev test, and a standard tier for the enterprise grade. Within standard tier, we have a S1, S2, S3. You see the differences here, in terms of storage, there is a difference, right? Not only in that, number of indexes, everything changes, especially the storage changes. So based on your needs, you have to choose either of these. And the other option is the storage optimized. Say you have a huge amount of data that you want to put it into your search, then you will be using the storage optimized. The cost will be totally depends on the offering that you select. So if you do a simple calculation here, the basic search will be like about $75, and the standard search will be $250, and the storage optimized will be $3,000, close to $3,000. Again, this is just a very foundational price. It is not everything. You have to add up everything to come up with some calculated numbers. If I just come over here, we already discussed that, right? So the basic search one, the SKU itself, it's not going to cost you much, but the additional things that you add on top of that, it's what going to cost you the additional money. Now, is Azure AI Search expensive? Of course it is expensive, but the reason is that there are a number of features that you can select, right? So depends on your needs, you will be choosing the features. For instance, here I listed the top 10 features. So the keyword search, vector search, hybrid search, semantic ranker, multi-model search, and embedding, all of these, right? So when you add each of these, then it is going to introduce the additional cost. So not necessarily the Azure AI search itself it's expensive, but because you opted to select the features, that will add the additional cost. So do we have any alternative for Azure AI search? Of course, we do have a lot of alternatives. So depends on the need, you can choose the alternative. For instance, PostgreSQL. You have to understand that when you buy the Azure AI search, you are buying a product, but when you are using the alternative, it is not necessarily will give you all the feature, rather it will give you a portion of that, and you have to do the configuration or do the additional development. So the additional development will also come into the picture, that is going to add you the cost. In general, if you think that you will be using at least 5 features provided by Azure AI Search, then I would say just go with Azure AI Search. Okay, so far we discussed a lot about the various type of search and the SKUs, use cases. Now let's try to implement that. So before we do that, let's try to understand the skill set. I already told you that the indexer will be using the skill set to perform a specific action. So if you see here, this is how we can define the skill set. If you see here, I'm creating a split skill. So basically what it will do is that it is going to split the pages. Say you're uploading a PDF file, 100 pages. You don't want to put everything into the same chunk, rather you wanted to split the PDF into chunks, right? So that is where we will be using the split skill. And if you see here, maximum length it's 2000, and the overlap will be 500 characters, and we will be creating the chunk out of that. And the same way we can also create the embedding skills. So that is going to take the split content and convert that content into the embedding. And we can also use the entity recognition. So you extract some data. From the data you wanted to extract the person, organization, or any other information or entity that you wanted to extract, you can very well extract. And when we talk about the pipeline, I already showed you how does the pipeline works. So you will have an indexer. It's a scheduled indexer. It can be scheduled, it can be manual. So indexer will talk to the data source, and it will extract the data, and the indexer will use the skill. It can use multiple skills. First, it can use the split skill to split the document, and it can use the embedding skill to convert the split data into the vector, and finally it will create the index and commit the index, so that the committed data, the index, will be available for our consumption. So now let's talk about the chunking here. So let's say I have a page, so 10 pages page, right? So I don't want to say complete page into the vector. So usually we will be splitting that into a number of pieces. If you see here, page 1, page 2, page 10, whatever is that, right? So we will split everything and create a chunk for that particular page. And when we say we wanted to create a vector, how do we create a vector, right? So typically we will be using the embedding models to create the vector. So you have to remember that you are using a specific embedding model to create your vector, and when you do a search you have to use the same model to create the vector so that you will get the results back. So if you see here, like there are two different models available for us, like there are plenty of available, but then like these two are from GPT. So the small model and the large model, the small model will be having 1536 dimensions, where like the large model will be having 3072 dimensions. The accuracy will be 62.3%. This accuracy will be 64.6%. So basically, like when you wanted to have the precise search results, then you need to use the large model, but the cost will be very expensive. So if you see here, this is 0.2 cents, where like this is 13 cents. So it is extremely high. So now let's move forward. Now this one explains how does this embedding works. Now that we understood everything, let's go and set up the search here. So first we will create the keyword search. We'll have the data source using the indexer. It will create an index. Let's go to the Visual Studio Code. So if I just come over here, the way we implemented, it's like first we create a data source. Let me go here. So it just creates the data source here. Once the data source is created, then we can create an index. So basically index, it's just a table, right? And then like we will have our indexer. So the indexer will populate the index and finally we can do a search here. So if I just come to the search here, so what I wanna search, it's like the cyber, it's what I wanna search, and I wanted to print the results here. So I already executed here, and if you see the result, it is just giving me these two, because like it is explicitly mentioned here in the search, in the description. Here you see cyber, and here also you see cyber. That's how we implement the keyword search. And for the vector search, it is almost similar, except that if you just come over here, we will create a data source, we will create a index, and we will create a skill set. If you just go to the skill set, we are just using the embedding skill set. So instead of just the keyword, we will be using the embedding here, and finally we will call the indexer to populate the index, and finally we will do the search here. Exactly the same thing, but this time around we will be using the vector search, right? So we are using the vector query, and we get the result. So if I just come over here, so this time around, if you see here, it is returning slightly a different result here. So it is giving me the Terminator, iRobot, and Terminator. So let's talk about the hybrid search. Hybrid search in terms of implementation is going to be the same, but if you just come to the search side, what you will do is that here where you will be saying the both you will be setting here, right? The search text as well as the vector queries, both you will be passing. If you just come to the vector search, you will be just passing the query, vector query, but hybrid search you will be passing search text and the vector query, both you will be passing. That is the only difference in terms of implementation. And the result, it is going to be almost identical to the vector result here. Now let's also implement the hybrid semantic search. It will be exactly the same, similar to the hybrid search, except that if you go to the index, we will also have the semantic search configuration here. So if you see here, this is the semantic search configuration, where we say focus on these fields. Remember, this database has a number of fields. Out of that, these are all the fields that we wanted to focus on for the semantic search configuration. So give a lot of priority to this field, title field, and you focus on this film synopsis. Basically, whatever the content field that we configured here, the LLM will read as a paragraph and try to identify the information out of this particular paragraph, and this field it's what we wanted to focus on for the keyword search. So now the results will be almost identical, maybe the order will be slightly adjusted. Now we can go back to the Azure portal and see all of this. So if you see here, like I have the SQL database. So this database, it's what I will be using for the search. And if you see here, like I am using the pricing tier basic under replica 1, partition 1, search unit 1. And like from here only we can do the import, like whatever we have done through the code, that can also be done from the portal. So if you click on this import, that will let you choose the target. So in this case, this is going to be a SQL server, and like what kind of search you want to do. Here, like you can choose the database that you are interested in and the table that you are interested in. You can choose all of these, and then like you can choose the authentication mechanism. I'm not going to do that, but you can very well do that here. And also you can also add an index and search the existing index. So now if I just come over here, this is where like you will see all the data source that we added through the code. So this one for the keyword search, vector search, hybrid search, and semantic search. So all of these are added, and we are focusing on the table frame. And then like for some of these we have created the skill set. You can find all the skill set here. So the thing is that you can also create everything from here. It's a JSON format. You can very well do that here. So let me open the vector definition skill set here. So this is how you create. So just give it a name, give it some description. You can say like the deployment ID and the like a dimension, model name, input and output, and this is how you can create the skill set. Once the skill set is created, then you can create the index. So you can very well create the index here too. So let me open one of the existing index. So if you just come over here, field, it's what we wanted to define. So if you see here, like we have defined so many fields corresponding to the database table that we have, and whether we wanted to retrieve. This can be used for filter, sortable, face table, searchable, whatever is that we can choose all of these here. And the like if you have the semantic configuration, this is where you will see, or you can add it here. Vector profile also, like if you have one, that will be displayed, or you can add it here. So now let me open one of these, maybe like the semantic one I open. So if you just come over here, the field wise it will be the same field, except that we will be adding one additional field to store the vector information here. And the like if you just come to the semantic configuration, exactly the same thing, right? So the priority field, it is going to be this, and the content will be in this, and the keyword search will be using this field. And the vector profile, you can see it here. So this is how we create the index, and like finally we will create an indexer. When you create an indexer, it is like you can create the indexer from here, or open the existing index. Let me open the semantic indexer here. So if you see here, like it is going to, when you create the index, you can edit the index too, and these are all the information that you wanted to have to create the index, indexer, and like you can run the indexer from here. So it can be scheduled index, or it can be a manual run also. So now if I just come to the indexes, now let me pick up any one of this, maybe the keyword search. And if you do the search here, maybe like I'm looking for the keyword cyborg, so it is going to give me the result here. We can also work on the scaling. So if you just come to the scaling here, where like you can configure your number of replicas, partitions, and you can also choose the various pricing tier. And like if you just come over here, from here you can get the keys. And if you come over to the premium features, you can choose the premium features. So if you see here, like right now I'm using the free feature, so when like 1000 semantic ranker per month, it's free. But like if you go with the standard one, then the price will be added, right? This is how we can use the Azure AI Search. Thank you for watching.